we're going to take a look at some AP problems today. And you can see the year that's up here, and on some of these you can go look them up. There are some parts that we will not do, so like on this one we're not going to do D, because it may apply to something we do later on in the class. Okay, so let's do this. Let's let f be a function defined on the closed interval from -5 to 5, and then notice it's a closed interval, with f of 1 equaling 3, and the graph of f prime, the derivative of f, consists of 2 semicircles, 2 line segments as shown above. Okay, so semicircle, semicircle, and you got 2 line segments. Okay, so our first thing is we want to, for -5 to 5, we want to find all values of x for which f has a relative max or min. Okay, so if you notice, we're not looking at the endpoints. All right, now anytime you are, and it always says justify, so make sure you give a reason for this. All right, so part A, anytime we're talking about a relative max, okay, so we're doing a relative max here. A relative max is when it changes from, and think about this, maximum is when it goes up, then down. It's when the derivative is positive and then negative, because remember this is the graph of the derivative. Okay, so where does it change from positive to negative? So positive to negative and positive to negative. Okay, so here it's at x equals -3 and x equals 4. And we have to give justification. So at x equals -3 and x equals 4, because f prime of x changes from positive to negative. All right, so make sure you have justification and make sure it makes sense. Sign lines, again, do not give you any points. Okay, you have to explain. All right. Moving on, part B says, for -5 to 5, all values x at which the graph of f has an inflection point. Well, remember inflection points are when f double prime of x equals 0, okay, as well as changes concavity. Now remember, we're given the derivative here. The first derivative, not the second derivative. Okay, so when is f double prime of x equals 0? Well, this is going to look like a max or a min. All right, and changes concavity. So this is going to look like a max or a min on the graph. And this is when it changes concavity, it's going to go from increasing to decreasing or decreasing to increasing. Okay. So where does it look like I have a max and a min? Okay, right here at x equals -4. All right, right here at x equals -1. And at x equals, now, x equals 2. All right, so those are going to be our points of inflection. Again, when it says justify, you can say on here it's a relative max and min on f prime and changes from increasing to decreasing or decreasing to increasing. Okay, and lastly, part C says find all intervals, so we're looking for an interval on which the graph of f is concave up and also has a positive slope. Okay, so here we go. Concave up is when it's increasing. So let's just look at that. So it's increasing from -5 to -4. Okay, it increases again from -1 to basically 1, and it keeps increasing all the way to 2. Okay, and then it decreases again. Okay, so far we got that. Now, when does F have a positive slope? Okay, when it has a positive slope is basically when this is positive. Okay, so positive slope from -5 to -3. Okay, and again from 1 to 4. So when does this match up? So when is it concave up and positive slope? Okay, well here it's from -5 to -4. And then, let's see, what's included in here? 1 to 2. And this would be part of your explanation right here. Okay, because you found where it's concave up, where it's positive slope, and then you combine them together. All right, let's look at another one. Okay, we're going to look at a 2004 from Form B. We're not going to do Part B on here. We're just going to do Parts A and C. Okay, so the figure above shows the graph of f prime. So we got f prime again, the derivative of function of f on the closed interval from -1 to 5. The graph of f prime has a horizontal tangent lines at 1 and 3, okay, which we can kind of see because those are the relative max and mins of the first derivative. The function is twice differentiable with f of 2 equaling 6. Okay, so keep that in mind. All right, so part A, find the x-coordinate of each of the points of inflection of the graph and give a reason for your answer. Well, let's think about this, the inflection points. Inflection points on f prime, when they give us the first derivative, they're going to look like relative max and mins on f prime and change from increasing to decreasing or decreasing to increasing. Okay, well, where does that happen? And we're just looking for the x-coordinate, so it's at x equals 1 and x equals 3. And this is our reasoning right here. This is our justification. All right, part C. Let g be the function defined by x times f of x. Find an equation for the line tangent to the graph of g at x equals 2. Well, here, what we've got to do is we've got to find, first off, the slope of the line. Well, we've got to apply the product rule. All right, and we're doing it at 2. Okay, so 2 times f prime of at 2. So think f prime at 2. This is the graph of f prime, and f prime at 2. It tells us it's -1. Okay, f of x at 2. Now there was a reason for them giving us f of 2 equals 6. Is going to be 6. All right, so this is -2 plus 6, which is 4. So this is the slope of my line. Now I've got to find the point. Okay, I've got to find g of 2. Well, they give us g of x is x times f of x. So basically 2 times f of 2. Well, again, f of 2 is 6. So this is 12. So the point is 212. So now I go write an equation. Y minus 12 equals 4x minus 2. So we applied tangent lines in this case. So make sure you understand what's coming off the graph of the derivative. And I've got one more that we're going to go over. All right, it's this question right here. And this is actually 2004, number 5. Okay, and we're only going to do A and D on this one. Okay, so part A. Let G be a continuous function with G of 2 equals 5. The graph of the piecewise linear function G prime, the derivative of G, is given. And it's shown from -3 to 7 on that closed interval. We want to find the x-coordinate of all points of inflection of the graph. Okay, remember, points of inflection, it's when f double prime equals 0, or in this case, G double prime. But what it's going to look like is a max or min on G prime. Okay, and then it's going to change concavity. That means it goes from, on G prime, it goes from increasing to decreasing, or decreasing to increasing. And again, this is all part of your justification. You're just writing it out, what you're thinking in your head. Okay, so here this is increasing, but then it changes to decreasing. Okay, so right here, and it just asks us for the x-coordinate, is that x equals 1. Okay, and then it goes decreasing and increasing, and look, it's a relative min, all right, at x equals 4. All right, and again, that's my justification. All right, part D. Find the average rate of change of G prime of x on the interval from -3 to 7. Does the mean value theorem apply on the interval? Guarantee a value of c for which -3 to c is in between -3 and 7, such that G double prime of c is equal to this average rate of change. Why or why not? Now, let's think about this for a second. Is G prime, okay, does it guarantee? So what are the, for MVT, okay, what are the two things that you have to decide? Is G prime continuous? And yes, from the graph, it is continuous on the interval from -3 to 7. All right, but the problem is G prime differentiable? Okay, well, we don't really know this for all the way. All right, and I lied, this is actually 2008, sorry about that. Okay, so here we want to find G prime of 7 minus G prime of 3, or -3, all over 7 minus -3. Okay, G prime of 7 is 1 minus G prime of -3 is -4 over, that makes 10. All right, so 5 over 10 equals 1/2. All right, that means the slope equals 1/2. All right, now the question is, does MVT guarantee the existence of a value C? All right, the problem is this: do we know if G double prime is differentiable? Okay, we don't know that it's differentiable, okay, because we've got all these sharp turns here. Okay, and so therefore G double prime is not differentiable on the interval from -3 to 7 somewhere, because there are sharp turns. Now, I had to find this because it said find the average rate of change, so I did find that. That's 1/2. But I can't guarantee that it's differentiable. So be careful. Be careful about your explanations. All right, and be able to say, and one thing I did not say on this last one is MVT does not apply. Okay, and here is its reasoning.